There was a scientist who was doing a research on bacterial cells. Now, initially he noticed that the count of bacteria was 3 into 10 to the power 9. Now, these bacteria were increasing at a very fast pace. So he kept a count. After 5 minutes, he noticed that the bacteria were twice the number of the original bacteria. That is 6 into 10 to the power 9. After another 5 minutes, that is 10 minutes after the beginning, the count of the bacteria was twice the initial count. That is twice of 6 into 10 to the power 9 or 12 into 10 to the power 9. And the bacteria continued to increase in a similar fashion. Now the scientist gave up after half an hour. He just wanted the number of the bacteria after 1 hour. So can we help him out? Now what is the sequence of the count of bacteria? 3 into 10 to the power 9, 6 into 10 to the power 9, 12 into 10 to the power 9 and so on. Now look at the sequence. Is there something common? Look at the first two terms. Let's find the ratio. And we have A2 by A1 as 6 into 10 to the power 9 by 3 into 10 to the power 9 or 2. Let's look at the next two terms. A3 by A2, 12 into 10 to the power 9 by 6 into 10 to the power 9. Again we have the ratio as 2. And so we say that this sequence forms a geometric progression. And why is this? A geometric progression is a sequence in which the ratio of two consecutive terms is always constant. In this case, the constant is 2. Now we know the initial count of the bacteria, that's A or A1. After 5 minutes, the count was A2, that is 6 into 10 to the power 9. 10 minutes from the beginning, that is after 5 more minutes, the count was A3, that is 12 into 10 to the power 9. So which term of the GP are we talking about if we are talking about the count of the bacteria after 1 hour? That's right, we are talking about the 13th term, that is A13. And what would be the value of A13? This we can find by the formula for the nth term of a GP, which is An equals A into R to the power n minus 1. Here A is the first term, R is the common ratio. In this case, the first term, that is A, is 3 into 10 to the power 9. The common ratio, that's R, that is 2. So the 13th term is A13, that's 3 into 10 to the power 9 into 2 to the power 13 minus 1. We can reduce this as 3 into 10 to the power 9 into 2 to the power 12. You reduce this a little further and you get 1.2288 into 10 to the power 13. Or we can approximately say that the count was 1.2 into 10 to the power 13. So now we know the value of A13. And what does this tell us? This tells us that the count of bacteria just after 1 hour was 1.2 into 10 to the power 13. And we are talking about an approximate count here. And this is how knowing the basics of GP helped the scientist.